Okay, so here we have a couple of digital multimeters, and we have some activities to do in the lab today. So if you take a look at this meter, this is the 61320 made by the Ideal Corporation, and this is the 61340 also made by the Ideal Corporation. It's a little bit more of an upscale meter, offering more options than the 61320 has. So I'm going to start by undoing the probes and we're going to fill out the graphic in the book. Alright, so there we have the switch in clear view, and you're supposed to label a couple of things on your handout. So we're in the OFF position, obviously that's off. When I go to the first position, it's at the V with what may look like a squiggly line, but that's actually a sine wave, and that means that we've set the meter to read an AC voltage. And if you can look closely at the meter, you might see AC over here on the display. So go ahead and label on your graphic AC next to that position. And we go to the next setting, and you probably can guess that's for DC. It's got the straight line and the pulsed line. The straight line just means straight DC voltage, and the pulse line, or the dashed line, means that you're going to be reading pulsed DC. That's not a very common thing to do. Most of the time DC is just straight DC. Alright, moving up the switch selector, we go to the ohm symbol. Looks like an upside down horseshoe. The ohm symbol is where you place the meter to read resistance. So go ahead and label your handout resistance for that position. Alright, and then the last one that we will look at today is this position. This is for reading diodes. It's also for reading continuity, or it can be used for that. If I take the two leads and short them together, you may hear the tone that the meter produces when there's continuity. So if I read across something, like if I take this resistor and I just read across the leg on one side, you can see I have continuity there. So it's pretty handy for testing fuses. Alright? So in the next part of the lab, we're supposed to have the meter be on resistance and measure a couple of resistors. So I'll have a little container with a lot of different resistors in it, and they all look kind of the same, but if you look closely at the color bands that are on the resistor, and if you're an ETE student and you've taken ETE 101 and 102, then you know that the color bands mean something, and if you haven't taken those courses, you can just see that there's different colors on there, and that's fine. We don't care about the colors. We don't care about calculating what it is, because that's beyond anything that we'll do. I use the resistors in the lab so you can take a couple of readings and just become familiar with the instrument. It's the only reason that we do it. Alright, so I'm going to take the lead and place it on one side, and I'll place the other lead on the other side, and I'll get some kind of a reading there. And the reading is 0.983, but if you notice, there's a small K on the right side of the meter. So that's indicating that my reading is in kilo ohms. Okay, so scientific notation is very common in the measurements, and you have to pay close attention to that. So there's one, this one is pretty close to 1,000 k ohms. If I take another resistor and I measure the resistance. This one appears to be 1.192, or if you round it off, 1.2 k ohms. If you notice, I can take the resistor and I can swap it around and I can read it from the other direction. Because I'm reading resistance, it really doesn't matter, right, which way I'm placing the leads. All right, so during the lab, you'll measure a couple of resistors and just get used to looking at the display. In the next part of the lab, you test some fuses. Fuses come in a lot of different shapes and sizes, and using a meter to test them is a pretty easy thing to do. All right, so you'll have a chance to see these up close in class. This one has a resistor built into the middle of it. So this is a slow burning type of resistor. Here's just a smaller body resistor. Here's a regular old school size, and if you look close you might see the element going through the middle. And of course this is what you have in the automotive world now, the blade fuses. Now a fuse, electrically simplified, is really nothing more than something that provides continuity across 2 points. So here's my resistor again, and I'm using it to show you the lead on each side, right, of the resistor. This lead really is just a conductor built into both sides of the resistor. So it attaches to the circuit on one side and the other side, and then it offers resistance to the circuit for whatever purpose it was designed for. But if you look at the lead, I do have continuity across here. Just like I established a minute ago, right, when I did some meter readings. If I take the leads and I just put them onto one side of the resistor, you can see I'm reading virtually 0 ohms. And that means that I have continuity. The connection is continuous from one lead to the other. So the 0.2 just shows that there is a very slight amount of resistance, because a conductor will have that, but essentially it's a straight through connection. Just like if I shorted the leads together, what do I get there? I get 0.1, right? So it's very close to the same thing when I'm reading just the lead on one side of a resistor. So a fuse should operate close to the same way. If I take a fuse and I want to test the fuse, if I'm not sure, I just put the lead on one side, put the other lead on the other, and if the fuse is good, I will read a very low resistance, meaning I have continuity across there. If the fuse was bad, watch the display, if a fuse was bad, I would basically be reading that, just like I'm not touching anything. So a bad fuse is open, and when I put the leads on it, the display essentially won't change. A good fuse, when I put the leads on, the display will change like you see, and it will read a value to me. Now, some fuses do have a resistor built into them so they will not blow quickly, and if you notice this one, it's reading 20 ohms, right? So there is some resistance there, so this fuse is good. Even though it's not a low resistance, there is continuity there. What you'll do during the lab is I'll give you some fuses, and you just can't simply look at them and see if they're good or bad. I put a piece of tape over them. I don't want to catch you pulling the tape off either. So test it, see if it's good or bad, and then check your results with, with me. All right, so you'll have a chance to do that. Then you're going to test some switches, and I'll draw that diagram on the board for you. It would be a little hard for me to do that here because I don't have a second set of hands to do things with. But essentially, you'll have a switch, and that switch will be numbered. So this is number 2. And if I look at the switch, and this is nothing more than a computer power switch, right? When I power the computer on, I push the button and let it go. So I'll draw the diagram on the board that talks about how this switch operates, but in the end, when you get ready to do your lab, somebody, right, you're going to do this in a group of 2 or so, somebody will take the leads and put them onto the contacts here. Somebody else will push the switch button in. So right now I put the leads on here. If you notice, it's the red and the black wire that are on the switch, and if I come down here I can see the red and the black wire. So if I put the leads on those 2 and make sure I'm not touching the leads together, you see I have no continuity right now, which is good. If somebody were to push that switch button in and the switch is functioning properly, then my resistance would jump to 0, meaning continuity. And then if I let the switch go, it would return back to being open again. And that would tell you that the switch is good. If you suspect you have a bad switch, they're easy to test. You don't even have to take them out of the computer. You would just have to disconnect the end from the motherboard to test it. So you'll have a chance to test 2 or 3. Find one that's good, find one that's bad, and then you'll know how to do it. All right, and then the last thing we do for the resistance reading is to check out an ESD strap. So here I have an ESD strap. I have my meter on resistance. You may remember I talked about this the other day, and see how I'm using the clip to hold one lead. Makes it easier. I told you that it had a certain value. Let's go ahead and measure it. I'm just going to touch the other probe to the plate here on the inside of the wrist strap. And can you make out what that says? It says 1.006, but then there's a big M. Big M means mega. So the wrist strap does have a 1 mega ohm resistor, and it's a properly it's a ESD strap that's in serviceable condition. We'll just say that. All right, so that's how you would make sure that your protective material, your protective items are still working. All right, and then the last thing to do is to take a couple of DC measurements. Pretty easy. I'm going to put the meter over on DC, and I have a very common DC item here that you may recognize. I have to observe polarity, and on the item, right, on the battery, I see a plus sign on this end, so I'm going to put the negative lead on the other end, and then I'm going to touch the plus lead to the tip, and if this is a good battery, it should read 1.5 volts or higher, right? And is it reading that? It's reading 1.626. So it's definitely a good battery. In fact, it's a brand new battery. So here's a battery that came out of something. Anybody know how many volts are in a 9-volt battery? Too early for silly jokes. So where's my polarity? Negative, positive, 3.5. So that's nowhere near 9 volts. Now what happens if you put the leads on the wrong terminals? What happens is you just get a negative voltage reading. You notice the negative sign there? Negative 3.5. So you just look at it and go, oops, got the wrong one. Got the leads on the wrong one. All right, so measure a couple of batteries. Excuse me, that'll get you used to doing some DC measurements. Now, in the next lab where you're taking some power measurements, you're going to be reading the voltages on the computer. The way that we'll do that is you'll take a shorting strip and you'll attach it to the ground, and then you'll attach the other to the ground lead, and you'll attach the other end to the computer chassis somewhere. So now your ground is already connected to the chassis. And then you'll take the positive lead and whatever readings you're going to take, you're going to go into the back of the plug and just push the probe down inside the plug a little bit to make connection with the terminal inside there to take the reading. The computer will be on, it will be running, and you'll be able to take your readings that way. Pretty easy thing to do. I'll show you how to do it in the class, probably demonstrate once or twice, and then cut you loose to do it. Okay, so that's about it for the meters today. Let's go ahead and get started on our lab activities.